gentlemen, I am Dr. Momita Shagu, the co-coordinator of 1 week offline faculty development program titled as Solar Effect on Climate Dynamics and Renewable Energy Towards Sustainable Solutions, proudly sponsored by AICT Training and Learning Academy. It gives me immense pleasure to welcome you all to the second day of this enriching program scheduled from November 18 to 23, 2024. This program is organized by the Department of Applied Electronics and Instrumentation Engineering at Haldia Institute of Technology. Today we are privileged to have with us an esteemed speaker, Professor Dr. Chandan Kumar Chanda, Professor Higher Academic Grade at Indian Institute of Engineering, Science and Technology, Shibpur, Howrah, West Bengal, whose expertise and insights will greatly contribute toward understanding of sustainable energy solutions and climate dynamics. Before we proceed further, let us welcome our speaker onto the dais with a round of applause. Now I warmly invite our head of the department, Professor Dr. Uday Maji, to the dais. Next, I welcome Mr. Devdatta Ghosh, Associate Professor and Senior Faculty Member of AI Department, to the dais. Finally, I invite our coordinator of this program, Dr. Somu Roy, Associate Professor of AI Department, to the dais. We are deeply honored to have such a distinguished dignitaries on the dais today. Now let's honor the dynamic personality, Professor Dr. Chandan Kumar Chanda, with felicitation ceremony. May I request Mr. Devdatta Ghosh, Associate Professor at Department of AI, to kindly come forward and felicitate our esteemed speaker, Professor Chanda, with a plant as a symbol of our. Thank you, sir, for this warm gesture. To mark the importance of sustainability, we now move to the watering of the plant ceremony, a symbolic gesture representing growth, nurturing, and our collective commitment to a greener future. I would like to respectfully invite all our dignitaries on the dais to come forward and water the plant. Thank you for this wonderful start of our session. Now let me take a moment to introduce our esteemed speaker for today's session. Professor Dr. C.K. Chanda is working as a professor, higher academic grade, in the Department of Electrical Engineering, IIEST, at Institute of National Importance under the Ministry of Education, Government of India. He has earned PhD from the Department of Electrical Engineering, IIEST, Shibpur, and MTech from IIT Kharagpur. Dr. Chanda has over 36 years of teaching and active research experience in the diverse field of power and energy systems, and before that, almost 5 years in the industrial experience in Durgapur Steel Plant. His area of active research interest includes smart grid, stability and renewable energy with sustainable technology, etc. He is a recipient of Tata Rao Gold Medal, Institution of Engineers, India, Vidyasagar Award, Lotfi AJ Award and 20 Best Research Paper Awards in India as well as in abroad. He is actively involved in various research projects in the tune of 2.25 crore funded by centrally funded organizations like DST, UGC, etc. He has published 220 plus research papers in reputed national, international journals and conferences, including 81 research journal papers in ACI Scopus Index journals. He is a member of the editorial board and guest editor, chief editor of numerous reputed journals. He has authored and co-authored 15 books in reputed publishing houses like CRC Press, McGraw-Hill, PHI, and Springer, etc. 3 books under process. He has contributed 40 book chapters in international proceedings like Elsevier, Springer, and Taylor and Francis. 19 research scholars are awarded their PhD degree under the supervision of Dr. Chanda. Currently, 5 PhD scholars are pursuing research under him in collaboration with other government and private universities. He has evaluated more than 75 PhD theses of IIT, NITs, and other reputed government and private universities across India. He has visited different foreign countries including USA, UK, Australia, Japan, Spain, Egypt, and China for academic purposes. He is an expert visit committee member of AICT and Macau and academic audit committee member of different NITs. He is a member of board of studies and board of management of different government and private universities. He is also a government university nominated member for different government and private institutions, council member of government university, ex-faculty council member of Jadavpur University and expert member for faculty and principal selection committee as well as chairman of faculty selection committee for NITs, government universities and private universities, etc. He has organized different IEEE conferences as a technical program chair across India. He is a senior member of IEEE USA, fellow of Institution of Engineers India, fellow of IETE, Chartered Engineer India, life member of ISTE and ex-member of IET UK. So we are privileged to have Professor C.K. Chanda with us today to share his insights and expertise on the topic Futuristic Power System Advancement Using AI Technologies. So without further delay, let us welcome Professor Chanda to lead this session.
Sure, the thing is this, let me have a look at this presentation. The AICT technology, the subject is solar effect of climate dynamics and renewable energy towards sustainable world or sustainable earth. The moment I came to know about this author and the title, and this energy, especially this renewable energy is very, very close to my heart, to my brain. There is a huge difference between the heart and the brain as a subject is very close to my heart. I immediately agreed instead of a very, very busy settling the month of a politician. So let me talk about how our power system is going to be defined in the next decade or in a few years. So I gave this name Futuristic Power System Advancement Using AI Technologies, another AI technology, because you have to take the help of AI in different aspects. So let me go to the next slide. One thing let me tell you, and because this is a training program, wherever I go, I always advise my participants, at any point of time, don't consider it as a lecture from one side, not a broadcasting type of lecture. You are not listening to the TV so that you cannot interact. At any point of time, if you are having any kind of confusion in the back of your mind, you can immediately catch hold of this and please clear me. At the end of my delivery, I will give you 5 or 10 minutes time, but I always give my participants that scope. At any point of time, you can stop me and put the question so that it will be a little bit interactive kind of session. To any point, so let me explain one by one. And what for we are going for futuristic power system. Before going into futuristic power system, we have to understand the traditional one. Then only able to compare what exactly it is. The present infrastructure is overstretched and intelligent bulk transfer is limited. Hopefully you got this point, but the issue is, as I am involved in Amin Ali and the Pushoko now they have got a new name, the Green India in Delhi. In fact, tomorrow we are having a meeting in Delhi with Green India also. This present infrastructure is really overstrained. Our present capacity, if I am not wrong, is 450 gigawatt. That is our present installed capacity. I am talking from our country's perspective, India. And the peak hour, normally in winter we do not operate AC, but nowadays we operate AC because of the climate change. The peak demand is the tune of 230 gigawatt or 250 gigawatt. So even though we are having a 450 gigawatt installed capacity, but we do not have that much amount of transmission line and distribution network. This is one issue, very very important issue. And inter-region bulk transfer is limited. We know we are having 5 grids in our country, regional grids. And earlier, few days back, in fact, out of 5 grids, 1 grid was not directly connected to us. So there is a big issue. The biggest issue is the inter-region bulk transfer. We cannot transfer gigawatt of power from our northeastern part or the northern part or the eastern part or southern part. It is challenging. Theoretically, we are publishing paper in Scopus Index, because actually nowadays we show papers in 1 year, the ranking of the college will not go off and all that. These are theoretical stuff are there. And the issue is the real challenge of the practicing engineer. Very difficult to transfer. Because one of the important member of ERLDC Calcutta, very difficult. Every evening they are challenging. We academics do not understand much, only accept the publishing papers. But publishing paper and reality completely one engineering phase apart. It is a different issue altogether. And that's why the government and academic bodies are giving emphasis on entrepreneurship, startup, patent, that kind of concept which can be day by day, not simply publishing papers. So that's a real issue nowadays. We face it in every meeting. Cannot fully support the integration of renewable energy. I will discuss in my second half presentation. It is really biggest issue, no? If we think simple, we are all talking about renewable energy, sustainability of this planet. That's simply we generate solar energy, wind is available across 24 hours. But the moment we talk to integration of renewable energy, it's a very challenging task. Let me touch upon this point. Solar energy, DC energy generation, no inertia at all, absolutely zero inertia, and synchronous generator 3000 RPM. So we are trying to connect a zero inertia to a 3000 RPM inertia is a very challenging job. The way I can give an analogy, you are trying to catch a train which is running at 150 km speed and you are trying to catch the train. You are trying to get inside the train, it is impossible. Either the train has to stop or you have to run 150 km, the whole thing will be synchronized and then only get into. But there are thousands and thousands of conferences and symposiums and workshops on renewable energy. We never give emphasis on them for how to connect, how to integrate, how to penetrate. And in fact, this year in our investigation, we are trying to bring one subject, integration of renewable energy, as a new full-fledged curriculum in our IST we are trying to develop. That's a really challenging task, rather a hot task, very difficult. Low reliability of power outage. Yes, power outage. Nowadays industry delays, but the moment the power is going out of here, now it's very difficult to make the system in original state. It's very difficult issue. Fluctuating quality of power. Nowadays we are very aware of this quality of the power. The way we are aware of the quality of a cloth when we go to a shopping mall, we are so much conscious about the quality. Nowadays we meet the quality of the power. It's not the voltage and the fluctuations. We need the voltage set, the demand set management, the deregulation environment, market power. There are so many things that come in the new market, this electricity market now. So these are the very important part. Major source is fossil fuel. Unfortunately in our country, 70-75% generation is thermal waste. And again out of the 75% thermal waste, mostly come from coal waste. Thermal waste means it may be diesel waste, it may be coal waste, nuclear. Somehow we have to boil the water. Mostly we burn coal, and there are a lot of disadvantages. The disadvantage we are giving huge amount of carbon footprint, and in the climate, I came from my institution to this by putting my own AC inside the car. So November 18, I am using AC, and that's the climate. When I was your age, in the month of October, I used to wear sweater. So huge climate change. tremendous climate change. Even if I'm not wrong, this is going on in the 19th November 2024 in the scenario. So the huge amount of the issue, efficiency of power transmission is very poor with respect to the advanced countries. That is a very important concern. Almost zero customer participation. Because we are now working this power sector, we want to work rather in a deregulated environment. Whether you know it or not, the large customer in the western part of India, they work in a deregulated, but as a customer, we don't do. In 2015, I have seen in my own eye in China, in the morning you get up from the bed, there are 10 service providers, you pick up the price, the way you go for the communication. Whether you go for BSNL or Aircel or Airtel or Vodafone, depending on the price, and according to pick up or Jio, which will be cheaper, I will take it. I can throw that SIM and take a new one. The concept is not there in the lower level, in the customer level. We do not have that much of facility. But in the bulk customer level, bulk consumer level in the western part of India, they can choose a service provider. Nowadays, in fact, let me go with the funny part also, everything is recorded and we have to provide the AC. Nowadays, we also teacher has become a service provider. Rather than teaching from the morning to evening, you go with the documentation, lot of paper, you have become a service provider, as students have become a very good customer. So teacher-student is not the issue nowadays. And all the head of the institution has become an education manager. They are all managing the scenario. They are not the director and vice chancellor. So now they are terminology has changed, they are the education manager. So almost zero customer participation on it. Only customer participation is possible in one side if we use the smart grid. And let me tell you the latest information. In this regard, Assam, Bihar and Odisha has advanced a lot. In Bengal, to the tune of 1 lakh, that smart meters area are 70% of year which covered by smart meters. There are a lot of advantages. I come later also. Low billing and collecting efficiency, they are also doing the vigilation. If there is so much amount of thieving, theft issues and all there. In nowadays, in fact, in our country, the commercial loss is more than the technical loss. Just take an issue, and there is a 500 pages book on commercial loss, on theft issue in power sector. So that's another challenging issue really. So low billing and collecting efficiency is another issue. So key challenges. So these are the very important challenges, and you all young faculty have to take care of all. You are all old people with a few years and retire and all that. So reduction in carbon footprint is very vital, and that is your issue, the solar effect and all that. We have to bring the solar energy. India is very ambitious, a new era of grid operation and distributed energy resources. And lot of works. So here, this renewable energy is not a luxurious term, it is not a conference kind of term. If we put renewable energy, we attract a lot of participants. It's not that. Renewable energy is a pressing need nowadays of the government. By 2030, we need 30% penetration of renewable energy. So that's a pressing need from the government. New era of grid operation, they are following a lot of grid coding. I do not know how much I have half hour, but the grid coding is very important issue for the smart grid operation. Smart grid or intelligent grid, the way to define, and the distributed energy resources. Distributed energy resources, tidal, geothermal, thermal, mini hydro, micro hydro, mega hydro, medium hydro, and then the waves. There are so many: solar, wind park, solar park. There are varieties of sources, and you have to bring everything. Ensuring resilience of the network with the high impact, low probability event, that is a very important topic. Nowadays, I am offering my research in the resilience domain of power system resilience. Nowadays, we are all facing the supercyclonic storm, and whenever the supercyclonic storm is not a very regular event, the event is very less. Once in a year or twice in a year it comes, but it comes, it spoils everything. Maybe 1 month back, one week, a cyclonic storm used to be supposed to come and hit, but fortunately now. So we have to be prepared in the power systems, know how will we prepare, how the system will be resilient. Sometimes the students and faculty, young faculty get confused. Resilience means reliable and secure. Answer is no. Maybe let me say sometimes even they have to deliver these things in AICT, so sometimes they deliver in paper to make the thing little bit interesting. The banyan tree where I live in that side, the botanical garden is very robust tree. One of the large banyan tree in the southern part of Asia that is not resilient. It lost on storm, it damaged like anything, thousand branches were damaged. But small tulsi leaves, nothing happened on the farm, small leaves. So robustness means resiliency does not mean the robustness. Resiliency does not mean the giant structure. Resiliency is something very, very new in the power system and it completely new research and domain from the power system people. And a huge amount of your department is advanced in instrumentation based. So a lot of advanced instruments are structurally here to maintain the resiliency. The frequency is very, very less, but if it happens, God collapse and all the system will become resilient after that. So that's why it is known as high impact, low probability events like Amphan or Umphan, then Yash and all that. Managing demand and generation is another important issue, the deregulation environment. So all these things make the grid a very, very complex phenomenon. The grid is the only thing in this planet which is human made and the complex part of the engineering. I am not talking about electrical engineering, I am talking about chemical, mechanical, civil, production, any kind of branch. That the most complex man-made system is grid, if I move forward to the slide. And we all human beings come to handle that is not possible by the human being. So the best thing AIML has come and we will take the help of that. And AIML I did in a bunch of water, very interesting one. If I put AIML in any topic, the things become interesting. So transforming the energy landscape. I always speak the history part of this development last. So transforming the energy landscape in 1637, the French mathematician, philosopher René Descartes, probably know René Descartes is the inventor of two-dimensional coordinate geometry, Cartesian coordinate, the same gentleman. René Descartes predicted that it would never be possible to make a machine that thinks like a human being. However, the concept got changed. In 1950, the British mathematician and computer pioneer Alan Turing. I am all suggesting if you get time, read this book, Alan Turing. Beautiful book. You will study this book like a story book, you will enjoy it. You cannot leave that book, you have to finish the book at straight. Beautiful. I have gone through the book twice. Declared that one day there would be a machine that could duplicate human intelligence in every life. Very important, human intelligence, not the character, not the other parts will be copied by the machine. I say that boy is a very bad kind of boy, that cannot be said to that machine. Only the intelligence part will be copied. So whenever you talk about the robot, you do not talk about the emotional part, about the gender part of the robot, that we never say. Only talk about the intelligence part, and he declared in 1950, will copy, duplicate the total intelligence of human being, and really we are getting this nowadays. Even nowadays, during this corona phase, China had conducted that program, the students, those who are in USA, they become virtual augmented world. And that's the application of AI. They are in USA, but they are attending, not in physical mode, but in augmented reality. That's AI. And at present, we are at the intersection of artificial intelligence and renewable energy. But I do not belong to augmented reality, I belong to the power system domain. So I tried to bring these two important technologies, artificial intelligence and renewable energy, in one platform. I wanted to club these two things. Renewable energy is very attractive, and artificial intelligence is very attractive to the young generation and guardians. Whenever the students come for private colleges for admission, they ask, "You are having EIML course for 4 years?" They didn't take admission. Electrical? No and no. So that's the scenario going on, which is a substitute to fossil fuels, which are depleting and attributing to global warming with greenhouse gas emissions. AI is revolutionary in the renewable energy sector by enhancing efficiency, reliability, resiliency, reduced cost, sustainability, and facilitate the development of smart grid, microgrid that can better manage energy optimization and overall seamless operation. So my topic is how to collect this thing in one platform so that we're able to extract renewable energy and at the same time able to integrate seamlessly to the thermal based electricity. So after this, what is the slide number 4? So any question? I always want interaction. So if you can interact, then I will be happiest man. So you want to know something. Otherwise, you will be a broadcasting type of lecture and go in delivering lecture, you are listening. Any questions from any shape? Of course, if I know the answer, then I will, not that I know all the answers. No. But if you do not put any question, I will take an happiest man. Right? I will not give any option. May not, it might have, and I don't know the answer also. Why AI renewable energy? Why I think it show data-driven decision making. AI harness vast amount of data from energy systems with the help of sensors to optimize operation. So let me talk something. I'll give one example. The moment I came to know that your department is instrumentation-based development, so I tried to incorporate the one instrumentation slide, I mean the metering slide. There, how we are taking the data with the help of a smart sensor, feeding to the smart meter, and on which controlling. That is given example. Right? Introduce that slide later on. So it can handle huge amount of data. How this huge amount of data, let me give a very small example. I know you are all having this solar energy generation with the help of photovoltaic. I am not talking about solar energy in terms of thermal. You can go with the two. One the thermal generation and other one is the photovoltaic generation. If you do not ask me question as a teacher and as a enrollment, another I can put in the question. Which one is better, thermal one or the photovoltaic one? What is your answer from your end? Both are good. I'll explain later. You don't know the answer. Photovoltaic. Photovoltaic is not the ordinary silicon diode, it's a different kind of diode. It works on the range of electromagnetic spectrum, the vision ray and the infrared spectrum, it works the diode, electromagnetic spectrum. So, whenever you put the solar panel on the top of the roof of this HIT, how trillion and trillion data they created, let me tell you. So there might be, it happened, we do not know, the irradiance is varying, that you know. Even a boy of class 8 standard, they are also studying solar energy. The solar energy is continuously varying from morning 6 a.m. to 6 p.m. That's fine. We are not talking about that thing. So that data is continuously changing and tremendous. Apart from that, it might happen that cloud passes over the solar panel. What we simply know as the shading effect. But few days back, I was an examiner in Bombay IIT. He has done work under Dr. Siddhartha Dr. in the faculty of Bombay IIT. So how the cloud is going, that's a full-fledged PhD topic of IIT Mumbai. The cloud is having a different topology. Cloud is not that coming in the form of a elliptical shape or it's coming in a rectangular shape or square shape. Cloud may come in a different topology, in a different day, with a different greenhouse gases. So that boy's job was how to identify the topology of the cloud and how that cloud's inputting shade of the panel, on the solar panel, if the cloud passes, depending on the shape of the cloud, the topology or the shading will be that effect. The shading will be not always the perfect shading. This is one aspect. So if you want to try to extract the data from the cloud with the help of a satellite, with the help of GPS, you can able to collect the petabyte data, not 1000 megabyte, not gigabyte, not terabyte, but petabyte of data in a fraction of a second, in a sub-second level you can collect. And that data is not a fixed data, rather the data is continuously changing in a millisecond time domain. So the topology of the cloud, the structure of the data is a continuously changing. We human beings able to collect the data, we human beings able to control these things, and the photovoltaic shell. I am not going into details of the physics of the photovoltaic shell. If you want to go into little differ of the photovoltaic cell, and if you go in the equivalent circuit of the photovoltaic shell, and the topology of the cloud is like that, it is not that the setting of a tree, the fixed static, it's not static one. The cloud is passing. The topology is changing. Like every second it is changing. So every dynamics they are getting. You want some dynamics, you can I just now I saw it. So dynamics of the topology changing every sub-second level. And we are extracting petabyte amount of data. And that data we are trying to extract to the grid. Who will control? No operator can control it until and unless we try to penetrate your email. Rather, not email, AI rather. Email is one of the important component of AI. Sometimes it's the AI email, it's not that. Email, the deep learning, DLP, they're all 6 important components of AI. So that AI, we have to take that help of, if you want to handle the gigabyte, terabyte, petabyte data, nothing doing, we have to take the help of it. That's a simple example. And one fellow, South Indian fellow from MPD, full-fledged PhD with high patent, 4 IEEE transactions with cloud engineering very important. Growing importance, and the world seems towards greener energy sources, AI plays a crucial role in making renewable energy more reliable, more resilient, and cost effective. Cost effective in the sense, I do not know whether you know it. Nowadays, the solar energy is called a day power. Do you have any idea what is day power? Day power means the power. Renewable energy may be wind energy, and wind energy across the day we can get it. We can get wind energy in the daytime as well in the night time also. But solar energy is only available in the daytime. So whatever we extract from photovoltaic cell, that is known as a day power or day energy. Power multiplied by time get energy, so day energy. And at present I am talking maybe 1 year back, the price of this West Bengal Distribution Company Limited or CSC 2.5 rupees only. But if you burn coal, it comes in the tune of customer level 7.5 or 8 rupees. So 2 rupees day power, that is the solar power, not the wind power. Wind is not abundantly available nowadays. And that coal burning is again 8 rupees, and again we are contributing carbon footprint or greenhouse gases to the environment. So 2.5 and 8 rupees, we have to mark in a very, very right manner. Such that we customers, we never call as nowadays consumers, not the customer, when we pay money. So no consumer that business, that topic. It is now you operate the horse in a business model. You are all customers. So we all customers practically want to get the power in a zero price. After the end of the month, we'll run 4 or 5 AC, huge amount of heater, and at the end of the month, if we get a 100 rupees bill, we are the happiest man in this planet. So finally, to possibly know all this power, I mean these private players means Ambani, RPG Goenka, CSC, they are all the private players in the energy sector now. Even though they are the private players, but the electricity regulation body is under government. That is the thing. That is the only business model which is controlled by the government. If they say 25 rupees or 30 rupees in my production cost and the customer has to pay 30 rupees, I'm not able to pay in working in such a institution as a teacher. As a simple teacher of college, I cannot afford 30 rupees per month. Take 30 rupees discount. So the regulation under the government, So this regulatory body is trying to incorporate a market model or the percentage model of the power by West Bengal DCL as well as this TCL. TCL does not play an important role. TCL and TCL. I am not going into the mathematical model of TCL. Very difficult and complicated to understand and scale in this kind of data program. So the issue is this cost effectiveness is very, very important. Anybody is working on the market and percentage model of power, that's absolutely a purely complex mathematical model. Anybody could you play with your hand? No. So I'm not going into detail. That's a different model strategy. You use mathematical modeling involved with that. Large dimensional matrix. So optimizing energy production. I have not brought mathematics much. Maybe the second half, the lecture, this kind of lecture, mathematics people do not like. Even though my real ID here complicated or seriously understood math, so math is a very important subject in my life. So solar power forecast, that's very, very important. Until and unless we forecast the power, because in a grid, load is a dynamic parameter. We cannot control the load. We do not know at what time is the tube lights and AC off. We will never instruct the DCL Your supply is CSC, in India CSC supply is also there. So far I know. Is CSC supply or
No, it is
state utility?
WSP.
State utility. So before putting all the AC and light off, we never informed to chairman of state utility we are going to put on load. We never do that. So this load is a very unpredictable parameter to the production because somebody is producing it. Until unless KTPP or battery producing, you never get it. Somebody is producing the energy. There is a source, but we never instruct it. So load is a very good parameter to be directly connected with the grid. And thermal generation is very smooth generation, very shooting generation, but again some issues are there. Lot of disturbances here. And we are trying to interconnect the renewable energy, which is highly variable in nature. But maybe this moment's bright side is there, maybe after 2 hours, there may be a setting or clouding effect. And the variation. So much uncertainty we are trying to do. There are a lot of uncertainty model up here in a state estimation. Do you have any state estimation of Jennings matrix? Anyway, I'm not going into mathematics now. You need to coding there. So I'm not going into mathematics. So this state estimation model, the SCADA model you can employ here for this kind of predictions, you know. And we, until and unless we go with the right amount of load forecasting model, where so much variance is there, it's very difficult to maintain. I already in my class I give an example. If one guest or 2 guests comes in my house, I could manage. I could manage it, my wife could manage it. Okay, your friend has come suddenly around 1 p.m. It's not that my missus will go for prepare for another. Within 3 or 4 meals, she can manage 1 meal. But if suddenly if I get 10 guests without informing my wife, she will be in trouble. And after leaving, either I have to bring the food from outside or Mrs. will kick me out from the house. What could I hear? So you need forecasting. If I invite them, I have to inform the prior night, the 10 guests are going to come, whether you need the help of a separate food. I have to go for shopping in the market, from my Pole market and all that. Then it is possible. Similar with the thousands and thousands variants of this in the thousands and thousands of variations, so many unpredictable parameters in the field. And you will surprise you know in the grid core, earlier what is the grid range, frequency range? Voltage range, I am not talking about the voltage because my topic is basically no frequency related. Because the hot voltage generation is zero inertia and thermal is 50 Hz. So if you concentrate only in the frequency variation, the frequency band to what? 49.5 to 50.5. Do you know this band to frequency variation? Do you know it? Very recently, last 5 years, they changed the grid because of the penetration renewable. We are trying to follow USA. We are not USA, but trying to follow US and Australia. Our bandwidth has become a little bit tighter. Not 49.5, 49.9 to 50.05, not 50.5. It is already instructed by the grid India people. You have to operate or you will be penalized. You will be penalized for that. The way I heard sometimes also hear that the private institution faculty a little time they are putting appraisals in every year for their promotions and all that effect. The same instruction has come to government instruction. Kick out after the age of 55. It's already instruction which comes. And the thing is that after 30, the moment you attain 55 years old, you have to fill up the 30 pages appraisal form and director is not satisfied, you will be kicked out or you have to go for VRS, voluntary retirement scheme or CRS, that letter has already come. And if cannot director kick out 2 faculties every year or every month, director will be kicked out from the even we are laughing, you know, this is the thing happens in Calcutta. During Puja area, every police has to give 2 cases. You are going with a car, but suddenly you will get one that punishment, oh, you violated this rule and all that, you have to pay the money, 100 rupees go to law and pay. You have to give 2 cases in every day. Otherwise, the job is highly unstable like again. Very difficult. So these the things are there. So that order has come to our director, all the right is all I can come. They have to kick out 2 senior faculty from your institution. Otherwise, your job is unstable as a director. That order has already come. You took 15 days back, they come to your institution. and private institutions are ready to accept digital. Not falling to it for it. Or in 2020 or little bit older, a 22% increase over 2020, and hence it is extremely important to predict the solar irradiance which plays a vital role in estimating the solar power production. Solar power production depends on weather, on climatic condition, speed of the wind, how much soil effect is there on the panel, it reduces the efficiency, the region of dust on the solar panel. There are a lot of parameters that are involved with it. So this is another important issue. We have to apply IA. Wind energy management, machine learning, adaptive algorithms, optimize wind turbine operations by predicting wind patterns and adjusting turbine schedule. Why this is required? No. In case of wind generation, how many types of generations are there in wind? Anyone else from your side? Two types. One is wind turbine and another one is windmill. Windmill means, say I am having a small factory in Haldia or Gujarat or Durgachok, a small sugar factory or that the Haldi river is very nearby to Mysore. So if I want to produce power, that is called a prosumer, and produce power at the same time energy, that is called a prosumer. So that is a windmill. I can use it windmill. And wind turbine is basically a large turbine. So windmill, if we incorporate into the grid, is very difficult because that consumer is a very peculiar consumer. He is taking the power in his own way, but the moment the power will be surplus, he will be in a different mode. One is an isolated grid connected mode, and another is a grid connected mode. Whenever it is in isolated mode, we are fine, it is not connected to the grid. But the moment it will be grid connected mode, we are completely in the uncertain stage. How much power will be consumed? After the regenerating excess, then you send to the grid, and that is static to be predicted very accurately, other than the grid instability will come. But we here we never follow this. If there is excess, then let them suffer. And 22% increase over 2020, and hence it is extremely important to predict the solar irradiance. And it is very, very important, no? In Eastern, I am always giving the real data. I always tell my the young faculty, go some real calculation rather than mathematics, AI and all that, using all buzzwords and terminologies for promotion, different, all that. Those are the days gone by. You have to think in a real term. One fellow is there, is a very senior rank in ERLDC. His same name, you can search the Google Chaman Kumar. He came, sir, he came to do PhD under me, but unfortunately I did not because my year is limited in ISP, my service span. But sir, in every evening, I think I leave this ERLDC job. Why? But sir, in evening time, it's very difficult to control the grid. I mean, Eastern grid, so the grid frequency changing from 49.2 to 15.8, and my bandwidth is very, very less. And anytime the system can go out of gear, and if it goes out of gear, my service will be again out of gear. Because every moment I am thinking, sir, let me go with a PhD and I will go to academics. And someone who are think academy is also unstable nowadays, not easy task. Highly unstable, stable is coming academics too. So he told 11% penetration of renewable energy in the eastern part of India. I mean, we have Jharkhand, Odisha, the northeastern Assam, and this side. They cannot manage the grid in the 11 time, at evening time. We are delivering lecture hours together in the symposium or all, that is fine. But those who are working in the real time, it really they are tension phase. Also, my blood pressure goes up to 150, 160 in the evening time. What to do, sir? I have to do PhD, I will seek my job. That's the scenario. So, 11% penetration is the scenario. A manager rank wants to take the job, if there is 22% penetration, and we know something is ambitious planning, ambitious that the penetration of renewable energy 30% by 2030, we do not know what will be the scenario of the grid in a very, very, very narrow bandwidth grid operation. Very, really challenging.
What is the voltage bandwidth?
Yes, sir. Voltage bandwidth we are a little bit. Yeah, that's very, very important. Most that I want. Whenever you talk about this inertia to discuss, no, it is completely voltage dependent and frequency dependent load. Okay, load may be different. No, there are three types of load: impedance load, constant power load, the induction motor load is a constant power load. Whenever we talk about this inertia, the renewable energy penetration, we only concentrate on voltage dependent and frequency dependent load. Whenever the voltage fluctuates, no, we say we integrate the renewable energy to the grid. Simple. In a very lecture. Not diagram, this pen and paper, black and white, delivering CKC lecture, everything is fine. But the moment if you want to connect, nowadays students are faculty that will research optimal location of renewable energy penetration. You have a lot of research paper, optimal. You have to go with a right point of connection, that is known as point of coupling. Until and unless you choose the right point of connection, whatever you share, the voltage regulation is the biggest issue in the grid. It's very important issue. And so, voltage regulation, voltage sagging, voltage profile maintaining, we simply share with the help of the fact devices, with the help of STATCOM, with the help of ABC grid, all theoretical ideas. If you cannot connect the renewable energy at the right time and at the right point, not the optimal point. Optimal is a vector. Nowadays the thing has come. Optimization technique. There are thousands and optimization technique and crores papers are coming. Grey wolf, ant colony. There are a lot of things in the name of nature science fair and some out which come at the MATLAB. Now I call it not a MATLAB, it is a kind of a monologue to produce a paper. MATLAB has become to be monologue. So that we are applying monologue and getting something and we are producing paper. How many paper? 220 plus papers of physics. So that kind of numerical data has come nowadays. So the thing is that, so this is very important from practical point of view. As an information practical scenario in CSE. I am one of the member of CSE, or very horrible class. And their penetration in the 18 or 25% is renewable. So voltage plays a very important role. And for this voltage regulation at that point, we have to take the help of AI. We operators cannot control it. Very difficult, very difficult. I think this is your question or you want to do something?
Sir,
So yeah, that's right.
sir,
Yeah.
one question is there.
Yeah.
I think if there is a consumer
Mhm.
who is using renewable energy.
Don't say nowadays consumer, say customer.
Customer, customer using renewable energy sources like solar or wind. Okay, when he or she has some excess energy and want to put it to the main grid. Okay, then how he or she will understand whether it is synchronized properly or not.
That is very simple task and not as simple, nothing is simple in reality. Solar energy is DC generator. Say you are producing the DC. If you produce from the windmill, that depends on the speed or velocity of the wind and it's very small. No? So that is a inertia is here. In the wind, inertia is here, but very small. It's not a very solar generator. So your first job, you have to go for a DC to DC converter. From there you have to convert finally inverter. You have to bring to AC. After bringing to AC, whenever you go for synchronization, there are three parameters have to be maintained. One is the phase sequence, is always RYB in the grid. Because thousands and thousands of alternators are connected with RYB. So we need RYB. We need not think about it. Another is the voltage magnitude. And another one is the frequency. So through inverter, you have to bring that 50 Hz because in our country, one prime minister, one president and one frequency, that is 50 Hz. But there are so many chief ministers like Didi and all. So at one frequency follow 50 Hz, not in our country, most of the countries in the planet go for 50. Australia 60, USA 60, Japan 60, advanced countries they follow 60. I don't know the reason behind it. They have gone for 60 Hz. So 50. So you have to bring to 50 Hz, but before 50 Hz is not an issue. But if you are able to change to 50 Hz, synchronization is not an issue. But easily, if you try to connect a small amount of generation to a classical grid you wanted to mean by name grid, you said no, it's tough, it's very challenging, tough. So there are a lot of multi-level integration is there. You have to create a grid, then before that sub-grid, then sub-sub-grid and all that. The way transmission, then sub-transmission, then main distribution, then sub-distribution, then it comes to the consumer. We generate the voltage in the tune of 11.5 kV, then hook up to 132 kV of 20, then it comes down to 400 voltage, then 220 kV. So similarly, step up, step down, similarly. Otherwise, say you are generating 100 kilowatt, you cannot put into, say, 250 gigawatt grid. It's very difficult. Mathematically it's okay, when grid it connected. Mathematics okay, do it, no problem. But the moment you do it really, it's very, very difficult, very difficult. Such a small amount of power, such a grid. But frequency have to be 50 as well. Otherwise you cannot. However, that is the challenge. Any renewable energy, we can control it. Because the inverter's frequency control, we are having the frequency response devices. We can control it from 49.9 to say 50.05. But what about that thermal side? That is controlled by the automatic component control AEC. And there might be a disturbance. This is there, everything is there in the second half. I don't know how much I'm going to penetrate, but time is limited. So there, the controlling frequency is very difficult because they are the bandwidth the 49.5 to 50.2 or 50.5. So one bandwidth we are falling from the classical generation and coal-based thermal generation or diesel-based thermal generation, and from the renewable is another very tight band. And again, government is telling Modi has told, no, it's not 49.9, it should be 49.97. You have to follow like USA. Trump has come, but Trump is saying you have to follow it. So 49.97 to this. So our band is gradually very tighter and tighter. Very difficult to control it. So any questions from your end, from the audience side, from the faculty side? If not, I'll continue. So wind energy management is very, very important. You know, ML, let me explain ML and all that here a little bit. Alright, later on. After 2015, this is a very good important slide I got then. And 2030, check the brightness for how much amount of power is required, and at the same time, coal is depleting, coal is a finite source, coal is a fuel which is a time-dependent function. It will deplete with the time. But if you talk about the solar energy, if you talk about the wind energy, it is not a time-dependent function. It is not that after 100 years there will be no more source energy. It is a time-independent function. Mathematically it is not true, but in human time scale it is true. After 10 to the power 6 billion years there will be no sun. In a human time scale we are bothered. We are never going to live after 10 to the 6 billion years. So if we talk in terms of human time scale, the sun's solar energy is an independent function of time and infinite in this area. So that the solar energy is infinite in our hand, very clean and green, but technology is very different now. And at the same time, 2030, that is the brightness, so much amount of energy we have to use. 450 at present is the capacity. By 2030, we have to achieve 750 gigawatt. Remember the word giga, not this mega. So this much amount of installed capacity. The thing is this. Because there nowadays our domestic load has gone, we sometimes discuss in every house there are Sasuri, mother-in-law. She enjoys all religious movie and religious TV. You young people, the tension or one more TV. Son is having one laptop, daughter is having 3 laptops, one for institute and one for this. There are two fridges, one for veg, another for non-veg. So many electrical and electronic gadgets. And domestic consumption has gone like anything. And the radiation energy consumption in residential level. So imagine the intentional AI for example, enhancing grid management is really very, very difficult task. Smart grid operation, AI enhances grid stability by predicting energy demand and automating distribution. Load forecasting, AI predicts energy. Let me a little bit, because I started around 10, 15, 11, let me a little bit first. Load forecasting, AI predicts energy consumption patterns, enabling better balancing of supply and demand. This is the only commodity we want this power system in a deregulation environment, in market environment. The way we go to Durga Chowk and supermarket or some shopping mall in Durga Chowk, there is a marketplace. Lot of shops are there, and we as the market players go. Electricity is like that. There are a lot of market players that they can go and purchase the market. But what is the difficulty of this potato, onion for changing and the electricity, who can answer it? What is the basic difference? The difference is the moment we generate electricity, we have to consume it at that instant. If there is a surplus of electricity, there is a cost of frequency variation, frequency will go. If there is a deficit of electricity, the frequency will fall down. But if there is a surplus of onion and potato, now the deficit of onion is going on, the price of onion I do not have earlier, now it is 90 rupees. It should be 30, 40 rupees. So it depends, we can store in a good hour. But electricity, unfortunately, we cannot store in a good hour. We can store in a battery, and battery technology, new technology. We do not have the lithium. We bring lithium from China. We do not have any lithium mines in our country. Of course, they have invented or mines in our very bad quality lithium, very small amount. So lithium and battery is very high density battery backbone. So we can, but it's very limited. We cannot store gigawatt of power in a lithium battery. So that's an issue. We can store, but very small amount. And again the question, after 4 years you have to throw the battery, you have to bring another battery. It is not that I purchase a battery for my cell, for my mobile, and it will continue for 25 years. After 4 years, I sell. So that's an important issue already. So this AI predicts energy consumption pattern, enabling better balancing of supply demand. So consumption pattern is very different. That's the smart meter and smart metering. What kind of load you are eating? Because you know, if you go with a smart kind of that washing machine, that fuzzy logic washing machine, they write what kind of cloths you are putting, you know, whether the cloth has a soil dust or the grease or oil or mud, that the sensor will sense the dust and the nature of the dust. Accordingly, it will operate the speed of the blade. Accordingly, that washing machine, that kind of detergent powder you use, or the amount it will fix with the fuzzy logic, the decision making kind of thing, and your smart meter will catch you this kind of washing machine you are using, the load character. Nowadays, by this hour meter, whatever the meter you use nowadays, the electronic meter, it cannot characterize our load. They simply give the bill at the end of the month, or if it is a state utility after 3 months. But they do not know what type of, because this AC load is a different kind of load. Our heater load is a resistive load, is a different kind of load. All characteristics are different. And the load characteristics are again in 24 hours, it's continuously changing. So we itself are generating mega types of data in our house. And the moment you put the smart meter, calculate the load, the CKC use this panel, AC machine, these are the things, these are the characteristics, and we charge accordingly. It is not the average load or any kind of load. Smart meter will capture or will try to extract all the features of a load at every instant, or in 15 minutes pulse that will extract. Because in our country, I guess, I remember, 15 minutes pulse. AI predicts energy consumption pattern will guess it. They will capture it every 15 minutes and enabling better balance of supply and demand. And predictive maintenance, proactive identification is very proactive. A human being is impossible. We have to take the help of AI and ML. AI is nothing but a tool. It's a tool by which I can control the slides. That's a tool. You know, those who are from the power system, the electric, you cannot be an AI expert. AI is a subject of computer engineering, So, but we have to use it as a tool. So, proactive identification and anticipating equipment failures before they occur, reducing unplanned downtime and maintenance costs. If there is an unplanned outage, will be that the service provider will be penalized. Say having a marriage program in the night, suddenly some kind of power cut from their end, I can penalize them. Some important program is here, your power is not there. Let's say I put another alternative diesel generator, I take 5,000 rupees for 1 hour for the, you have to pay that 5,000 to you. I can penalize both the communication. That penalty. So this unplanned, this kind of these things, it come into the play. Is proactive identification and anticipating equipment failures before they occur, reducing unplanned downtime and maintenance costs. Very important issue. You go to the market area. Everything is now under the scanner. Everything under CCTV. You cannot do any kind of wrong to the power system. Predictive maintenance, equipment health monitor is very important. Nowadays, once you put the estimate, you forget it. this is not the thing. Every moment you have to go for the health monitoring scheme. The way you go for the health monitoring of human beings, you have to health monitoring of every human say every instant, and the result is by AI. So AI algorithms analyze data from sensor. Here we can apply IoT based data. No? So data from sensor, smart sensors on equipment like wind turbines and solar panels to predict failures and self-maintenance before issue arrives. So before this arrives, we can take into consideration cost reduction by preventing unexpected failures. AI-driven PX maintenance increases the program loading factor. Really, it's very, very important. So energy storage optimization. People say that energy is the battery storage. Yeah? Sure. I mean, switch. That's a good question. I always love. Nowadays, battery technology is not a very satellite technology or not a rocket science. It's very simple technology, but the management of battery is really nowadays science. So that's why we call it a battery management system BMS and play a very important role for sustainable solutions. Energy dispatching, whatever you produce, whatever you integrate to the grid, somehow we have to dispatch to the customers, very, very securely, very reliably. And again, that can be done, because if you talk about the customers to the fact end customers, there are thousands and thousands tie lines and lines and feeders and all that. And to shell the power properly so that no transmission line, no distribution line should face any kind of congestion, we need AI application. In which line, how much power is going, how much active power, how much reactive power at that moment, what is the voltage level, what is the frequency, what is the power angle, delta, everything you have to calculate it at every instant, and for that we know the energy dispatching system and can be done with the help of AI. So AI is a really very important aspect. AI power marketplaces. AI facilitates real-time energy trading, balancing supply and demand, and enabling peer-to-peer energy transactions. Nowadays, what he told from the beginning, there is a marketplace for power in the western part of India. You can go and sell the power. Even if you are not an energy producer, you can work as a broker. You can purchase power from somebody else and can give it. The way you do in stock market. The only difficulty is this energy, we cannot store it. But we can use the stock market concept in a power sector. In fact, we are doing it with the help of AI and ML. That's a very big business model by AI. Blockchain integration. We are not using blockchain in our country. There are a lot of difficulties in applying blockchain. But sometimes in this kind of presentation, the student asks me, sir, in Australia they are using the blockchain, but we are having a little difficulty. Our country is not that much advanced. We are basically a developing country, not underdeveloped. Again, not developed also. So where the question shop, poverty is there are a lot of integrations in there, a lot of issues are there. So we cannot go directly to the blockchain issues, So blockchain integration, theoretically it is required for market strategy, for business model. So AI combined with blockchain enhances transparency and security, energy trading. But as I am talking from our country's perspective, I talk to a lot of senior professionals in the market domain. They talk most have never used blockchain in our country. We are having a lot of limitations for using blockchains. Enabling smart metering. Smart metering, so let me say something about the smart metering. Smart metering, earlier when my age in the use of, I mean in the tune of 27, 28, so there is a meter, and that meter is basically electromechanical meter. Probably you have not seen in your life. Electromechanical meter means, we studied in Golding Medics, I have seen in my own eye, one induction disc will be there, outside is a fixed magnet and it will rotate. But input and output is open. So we people, without studying electrical engineering, we are very clever, we used to know how to think the power. So power is coming from the feeder, so you try to bypass the meter, so at the end of the month, see that West Bengal utility, this month we have generated this much amount of power, but where is the revenue collection? Because we are bypassing the meter as a consumers. So after a few years, they got the huge amount of stealing is going on in the power sector. So what they brought a compact meter. So input and output both inside the glass cell. If you want to thieve the power, you have to break that seal and you will be penalized. Again, we are intelligent enough. So anyway, the induction disk is rotating inside. So let us bring another powerful magnet and put outside it so that the speed of the induction can be reduced and we can steal the power. Then again, a few years after the electronic meter came, there is no rotation, there is no stealing of power, but the disadvantage of electronic meter is that can record, that the thing, nowadays, hot phase we are going on that. The electronic meter, it can record how much we integrate rather, it's kind of integration meter, how much power we are consuming. People used to come at the end of the month, they see the reading. So this was the last consumption. This is the consumption of today. Subtraction will be the reading, this electronic meter. But they have reduced the scaling, very difficult. You cannot challenge technically to that meter. So that electronic meter, or the difficulty of electronic meter is that somebody has to come at the end of the month to note down the reading. Electronic meter, again difficulty. If somebody comes and covers say 100 houses, so some outsourcing people is to be there for 50,000 rupees, 20,000 rupees per month. So they go with a automatic meter reading, AMR. Sometimes it is known as advanced metering instrumentation, AMR. Automatic meter reading. In fact, in my flat, AMR is there. AMR means it is not electronic, slightly advanced one, but communication is one side. Only they can communicate, I cannot communicate. In AMR, whatever the consumptions will be there, that will be reflected in their consumer. Nobody will come to my house, take the reading and all that. At the end of the month, they will get the information. Professor C.K. Sage consumed this much amount of power at this month, and at the end of the month they will send them. Nobody comes in for my meter. So that is AMR, automatic meter reading. By their computer they will get it. And then the advanced thing is come, the smart meter. Smart meter is a meter. Any idea about AMR and smart meter from your end? Smart meter is a meter. No? Inside the smart meter, there are three important features we have introduced. One important feature is the breaker. In CSC, what happened I can say, I do not know about your state utility as I belong to that side, bottom area. If I do not pay the bill at the end of the month, the color of the bill is blue. If I do not pay, say I am out of country or out of state, the color of the bill will be green. So that's a kind of warning to me, you have not paid the bill. Again, if I fail to do that, then it will, the color will be a slightly reddish color. That means in first warning you have failed to pay the bill, this is a red color. If you do not pay, or people will go and cut the meter. You won't be able to enjoy the electricity after 3 months. If there is manual intervention, somebody will come and do all these things. But in a smart meter, inside the smart meter there is a breaker. From their end, if you do not pay the bill at the end of the month, God, the breaker is operated, you are. This meter they have introduced the smart meter in the New Town and the south part of Calcutta they have introduced. About 1 lakh smart meter they have introduced. And within 3 or 4 years, maybe 1 crore meter will be installed in some sort of smart meter in Bengal. That project is going on. But huge amount of, do you know the price of a smart meter? The price of a smart meter is the tune of 20,000 rupees. But the price of electromechanical meter, 250 rupees. You go to electronic meter, 1200 rupees. So if we say we will implement smart meter in Bengal, so much thing is going on in Bengal, in Staranas, if you see the news and all that. So 22,000, 20,000 with smart meter will be employed every year is a challenging task, and crores will be project very difficult. So one important technical aspect is the breaker. They can operate the switch from their end. The people will not come and operate. That is one feature. Another feature is the smart feature. You can communicate from your side. No, I will be out of station for 15 days. I don't need your power. So they will generate accordingly. No. So they can generate. Say if the 1,000 customers gives information on 19th November. So this power we do not require. So they are able to control the power accordingly. So that's a greater advantage for them. Then we go for AC. Probably you know, if you go for first AC, we need not inform to the people. But if you go for the second AC installation, you have to inform to the utilizer and the service provider. Then they will come to know their demand has got increased. I have to change the rating of the distribution transformer. We generally do it without informing whether legal offence is there, that we have to do. So we can, not I can rather, we can give the information. And third one, like a mobile, there are two modes, prepaid and postpaid. In this electricity, you can go for prepaid, there will be SIM inside it. I can charge this meter for 2000 rupees. The moment it will be exhausted, 2000 rupees, 1 or 2 days back, will give a warning, you are going to exhaust, you are going to exhaust, please charge your meter. If you do not charge it, they will operate the breaker. So the way we go for the electronic SIM, the same kind of prepaid and postpaid will come. Electronic meter it is there, but come, if it already is there, we charge your meter for 5000 rupees. Before 3 or 4 days, it will go on continuously. Your only 100 rupees is left out, please charge it and all that. So these three important features are there. Price of the meter is very, very high. Very ambitious project by the government, state as well as this. And that's the smart meter is this. And only this smart meter consists of a lot of smart sensors, and smart meter will able to work only in the renewable energy penetration, and that with the smart grid. But the difficulty is whenever you talk something about the smartness of the meter, there is a kind of a layer, the communication layer is there, some Bluetooth communication or Zigbee kind of, I'm not a man of communication, so that communication layer will be there in the smart meter, so anytime it can be hacked. So if no technology is 100% blessed, if you talk about so phone pay, you can easily pay the money, but sometimes we heard in the newspaper, somebody's money has been stolen by some fake people, So if the thing becomes advanced, so similarly some cyber crime may come, but a lot of layers, security layers we are trying to provide, but sometimes those people, cyber crime people are much more intelligent than us, they can crack that security level, they can again do the mischief and all that. So there are some negative aspects are there, but still technologies are trying to incorporate that. So that's all of the smart meter. And so much change has come, and everything is possible by email. And another important feature of email, what kind of load you are using, they will able to feature. You cannot hide the game. It is not a hide and seek game. They will able to extract the features during 24 hours in a 15 minutes game. How many hours have you used your washing machine, how many hours have you used your micro oven, how many hours have you used the electronic oven, everything, how many hours have you mixed it. All the features of your load, they will be captured in the help of a smart meter, and accordingly they will not bill you on the basis of average load. Depending on the characteristics of the load, the way you go for a restaurant, and depending on the item, they charge chicken this, mutton this. So they will charge the characteristics of the load, they charge from the smart meter, and they will charge you accordingly. Even during the peak demand hour, during the noon time, 12 o'clock to 4 o'clock, summer peak, there is a huge amount of demand, and they can, nano means it starts from 1 watt to 100 kilowatts in micro. But the microgrid is better because the generation is heterogeneous in nature. It may be wind, it may be tidal, it may be wave, it may be solar, and it involves a microgrid. And these microgrids are again two types, isolated mode and non-isolated mode, and we completely depends on AI and ML, and that can control it. Human beings very difficult to intervene. Optimization microgrid by coordinating various distributed energy resources. Demand response, I already told, with the help of a smart meter, the service provider will ask you, please wash your dirty clothes in the evening time or in clean hour, not during the peak hour, where having a huge demand of the power. So finally, energy optimization, this is the art and science of maximizing the efficiency and output of renewable energy system, fostering a seamless integration of renewables into the existing energy infrastructure. This is the major components, 100 kilowatt peak floating solar. You know what is floating solar? Nowadays, because of the land crisis, we go for a solar or floating solar. This is a simple example of 100 kilowatt. In fact, this is an example of our state. It's a diagram from our CSE using this floating solar nowadays. Because of land crisis, political issues, geopolitical issues, a lot of issues are there. And state-of-the-art microgrid controller, floating solar, battery bank. A real diagram for state. The climate impact, your topic is the climate related, environmental monitoring, AI tools analyze data to access the environmental impact. Every topic, everywhere, you can start your page and get it. Every 3 letters, every 3 sentences is a new domain in process. AI tools analyze data to assess the environmental impact of renewable energy project. helping decision making for sustainable development. Carbon footprint reduction, oh yes, it is a very simple task. If you go for a renewable energy like solar, wind and all that, the important issue is this, we can reduce the greenhouse gases like anything. That's the plus point, no doubt really. Carbon footprint reduction. But let me tell you, whenever you talk to like a blind people, but some amount of greenhouse gases is required for our health also. Whenever you talk about greenhouse gases, knowledge bad, knowledge is very bad. We have to greenhouse gases. Otherwise, with a small amount of greenhouse, the ozone layer will not be there. So we require greenhouse gases, a small amount. Or whenever you talk about greenhouse gases, we think that the most bad element is that it's not that. So AI optimizes process across the renewable energy sector to minimize carbon emissions, driven by increasing awareness of climate change and collective commitment to reducing reliance on fossil fuels. Nowadays, in fact, in our country, we bring the coal from Indonesia and Australia. They are fully dependent on their renewable energy and it's very expensive affair. So finally, let me go to the concluding side. So AI is really a game changer, no? It's a game changer in renewable energy. Artificial intelligence is driving significant advancement and stands out as a transformative force in the renewable energy sector, capable of enhancing efficiency, reducing cost, improving reliability. In fact, under AI, there are six important aspects: fuzzy logic, expert system. Those two are basically decision making. Whether it will do it or not, basically binary kind of decision making. Whether it will come to FDP, even though I am having examination duty or not, I have to take a decision and accordingly I have to maintain my commitment or I have to inform the organizers. The binary kind of decision is going on in my brain. And then another is that ML. ML is basically a component of AI, supervised, unsupervised and reinforced. Supervised means like a human beings. Everything has come from the nature. If I take a probationary training how to teach, whenever the teacher goes for teaching in the school, they go for a B.Ed, Bachelor of Education, M.Ed, they go for a 1-year course how to teach the students. They are 14, 15 years old, handling of that age is very difficult, So how to teach, so that's a kind of a training. So whenever you get some data, so that data we have to train. Once we train 60-70% of the data, then we give a new data with a lot of noises. Then data will be processed with the help of the raw data and we will be able to get a good output. Whatever we do in a B.Ed or in engineering, there is no B.Ed level it is required, but in a school level it is required nowadays. So that's a kind of a training linked to the data that is supervised. Unsupervised means it is not required. What we do? We give the data, we assume that the data are perfect with some kind of rawness. We put it into that. If you find the output is not to our satisfactory level, that's a kind of a feedback control. That output data again we put the input, we process it again and again, filter it again and again, and we finally very good output. Then it becomes supervised. In case of unsupervised, less amount of data works nicely. Both the things are having advantage and another is reinforced. Reinforced is basically a combination of both. And another one is the deep learning. Deep learning is basically neural network based. There are a lot of layers inside it. It works like a human being brain. So we'll give the input. That input will be processed inside it like a human being brain in a neural network. Finally it will go to the output. We are satisfied, fine. If not, again it will follow the feedback path. Again it will be processed. It will go, it will be processed and processed and processed. So that everything happens inside the machine in a neural network strategy. All are basically kind of computer algorithms. They're all computer people. They develop, we give the information to them, they develop the algorithm, they're all algorithms. So we electrical engineer, we do not think and bother about it. Sometimes what we'll do, every other reagent, try to learn MIML, but that is basically a tool for us. Let them learn the way computer people never learn this voltage stability for electronics. So why will go into details of AIML? Something you have to understand about AIML, how you. So this phone is with me, this iPhone. I do not go into the electronics part. I know how to use it. That's all. Who will go the memory design and all that? Let them design the memory, how this works in mobile. So let them design. The people are there, the iPhone people in USA, they do it and let them do it. They are the electronics people, they do it. I will use how to use it. How to communicate with Professor Uday Maji and Somora. If I understand, that is more than enough. That is the application of this. So the key benefits. optimized energy production. The profound impact of AI ensures maximum output from the renewable sources by analyzing real-time quality data. Whatever we do in a paper is all offline data. Offline data is individualized data. We have to take the real-time data. So real-time data analysis is only possible by AI/ML, or with the help of IoT-based data can help. Otherwise, we cannot. Offline data is absolutely useless. No? So we cannot get the exact features from the offline data. Enhance grid stability, AI to grid management, balancing supply and demand, even with the variability and intermittency of renewable sources, predictive maintenance by predicting equipment failures, AI reduces downtime, and that I already explained. No? Future direction, future prospects. The integration of AI will continue to play a pivotal role in the transition to a sustainable energy future, supporting the global push towards carbon neutrality. And for that reason, we need a lot of models for paper publishing and the real life expert system, ELM, sub-vector machine, ALM, that neural network, neighborhood, ML, machine learning, deep learning, shariness, LSTM, ANIMA, anyway, basically reliability technique, the particle form optimization, to name a few. There are nowadays hundreds and hundreds of optimization techniques are available. Even when I deliver a lecture, in the meantime, somebody has developed one optimization technique somewhere in this setting. So these are the things now we apply as an algorithm for AI/ML application. So call to action. So that's very, very important. These are the things are available. Embrace AI-driven innovation to lead the change in renewable energy transmission, ensuring a cleaner and more sustainable world for future generation. What your topic demands, we need the sustainable solution. We have to go with AI, we have to go to renewable, and hopefully, I'm not sure, maybe the last slide is the title slide. Yeah, thank you for patient sharing. So any questions from your end, I'll be happy to answer you. Let me tell you, as young faculty, those who are wishing to do the PhD and all that, from every slide, you get a clue, you get the idea, you get the topic, you can pursue your PhD. It's not ordinary renewable energy. AI/ML, IoT-based, smart grid, smart meter-based renewable energy you can work. So that's all about from my end. For the first step, second up, I attack one issue of this penetration. The inertia issue is very, very important, and I'll talk about it. And really, and Bombay IIT, they are having they have a different energy department, and they are one South Indian professor is working in the inertia estimation of renewable energy. Chennai IIT, Bombay IIT, and a little bit of Kanpur IIT they are doing it. I am involved in Bombay IIT energy department, so I have a certain amount of real idea of the estimation of energy, the inertia calculations, and if possible, I'll deliver in the next talk, cutting a little bit rest. So any questions from your end? Any big questions? Now I am interested to, this is absolutely very new topic now.
Sir,
Right.
about the enhancement of the grid stability,
Yeah.
how we can use that
Energy of the grid stability means we are having a lot of grid code nowadays. The first grid code is predictive, not predictive, other kind of forecasting. Because in every 15 minutes we are getting a signal from grid India. What earlier knowledge Poshoko. Every minute you have to take the voltage profile, active power profile, reactive power profile, and the nature of the voltage profile, frequency, bandwidth, everything you have to predict within the 15 minutes. If those things are within the bandwidth or with the prescribed limit, then only able to maintain the grid. Otherwise, if you violate the grid code, then grid will be unstable and it will be out of gear. What happened? Probably you all know is very typical. If I am not wrong, 2011 or 2012, the northern part of India, the eastern part of India, there is a complete blackout. No? Probably you are a little bit older, so you can understand. Because in Agra side, they withdraw suddenly 90 megawatt of power from your local resources, and grid become unstable. That you cannot do. You are violating the grid. No? So if you want to take the power, you have to give the travel information, then only. That is very, very important. Anybody can come and listen my lecture, no, is coming. But some private intimation, you have to enroll as a listener or a participant, no. Suddenly it comes and you have come to, I want to, innovation, you have to think for twice. There's a crores and crores to be violation.
Sir, can we get the real data from grid India?
No, very difficult. Now, data is there in the air, but you want to extract the data, carbon dioxide, carbon monoxide, greenhouse, everything is there. So data is also there. If you want to take the data from here, through some media you have to pay the money. One of my students is going to be final defense, he is working on resilience. I wanted to correct the unfund data, and that time probably Dr. Sanjeev Banerjee, he was there, he used to come for weather forecasting. Nowadays another, he has changed, he has gone to Delhi side. I just collected his phone number, gave sir, I want some unfund data because one of my student is doing. Well, okay, we are having two versions of data. One data is the student version and another is the real data. So he'll give me the student version, great. So, many thanks Dr. Banerjee, you are giving these data. Also, many thanks you can give, but it costs 2 lakhs rupees for student version. And if you want to take the real data set, it is more than 50. We cannot provide the data just like that. You have to purchase it. And he told that I can subsidize the price of the data if you give 10 foot by 10 foot square feet inside the IST campus area. I want to put one sensor. So 1 lakh rupees and 100 square feet area inside the B college to put his device. Because they are central government, that meteorological department, our B college is central government. So their projects should be there within the central government premises. So he approached me. And I approached to a director, ex-director, Professor Chakravarti, immediately. No, not a single square feet is not being provided. Finished. So student version data, I could have got by giving 100 square feet land from my ISP and 1 lakh rupees. Then the Panjan told, sir, what should I do? I mean, what data you are getting from the Google, that Google uncle is here, he will provide a lot of data, all good see data. Take from them, run your MATLAB, get some data and submit it. So getting real data is very expensive and nobody will give you. Because the reason is here, he told that, sir, there will be no secret of that. You will give data to somebody else, you can manipulate myself. But if I go for money, you will think that I have collected the data by paying money. So if you want to give, you have to think twice. I will not give it freely. So data, getting data, right? I am talking about across globe, not your country. It's much more expensive than purchasing a gold. So everything you have to get from the net, whatever is available. No? Sometimes those data are good, but sometimes are not sure, quite sure. Getting data in green form. Yes, somebody wanted to put question on their side. Some lady faculty or somebody else. Yes, most welcome.
Sir, is recycling of this huge number of solar panels easy?
Not easy task. It is really a Herculean task and challenging task. Again, scientists is singing because the space is already polluted with the satellite. 10% of the space is already occupied by the satellite voltage. So again the government is thinking, we are all talking about renewable energy, sustainable energy footprint. Within 150 years they have calculated half of the Sahara desert to be filled up by battery. Battery is not a lifelong thing. Finally you have to throw that battery. And the pollutants of the solar panel is much more dangerous than the polythene. You know the lifespan of polythene? Why they not only obstruct the water flow in the drain, if you want to degrade the polythene, it takes 1,000 years time. And that's the lifespan of a polythene. And the lifespan of solar panel is more than 1,000 years. That's a dangerous content. And half of the Sahara desert will be filled up with solar panel. So what we are trying to increase the efficiency of the solar panel. We are trying to incorporate the material device. What kind of oxide will you use in the solar panel, which is degradable, biodegradable nature. And in fact, we are going to use biodegradable solar panel. Again after 150 years, next generation will face another kind of, it's not greenhouse gases, another kind of fountains will cover this planet. It's very interesting. If we are talking about renewable energy, but somewhere or other we are polluting. So recycling is possible, but it's limited technology is available and very difficult. But as far as the battery is concerned, we are recycling because we do not have the lithium ion battery. So we bring from China, and whatever we bring from China is not second-hand lithium ion battery. not the first and very expensive one. Use it and recycle it and use it. So the original lithium ion is very, very expensive affair, no? And China is a very rich country, the second richest country in the planet because of that thing. Their manufacturing industry is very strong and they are on the lithium core across this globe. We do not have. And all the battery share, all these mobile cells and all the lithium ions, you know. So they are all recycled batteries, you know. This is not that the original lithium ion. And lithium ion, the Bhubaneswar had working a lot. He had been there, we had set up and all that. I showing me, they're the people said they're all lithium ion paper. We recycle, bring from China and recycle it. Otherwise very expensive. But we have to recycle, we do not have the source. We have to purchase from somewhere else and what to do.
Thank you so much, sir, for this enjoyable and thought-provoking session. And thank you, participants, for your queries. In today's session, Professor Chanda gave us a detailed understanding of the challenges in traditional power systems and how artificial intelligence can transform the energy sector. Dr. Chanda highlighted critical areas such as optimizing energy production through solar forecasting and wind energy management, enhancing grid stability and predictive maintenance using AI tools, the potential of smart metering and energy storage optimization to modernize power distribution, and also how AI-driven innovations like microgrids and renewable energy trading can contribute to sustainable solutions for a greener future. His emphasis on integrating AI with renewable energy systems truly underscores the role of technology in building a sustainable and resilient energy framework. As we conclude this session, I would like to thank Dr. Chandra for sharing his expertise and igniting meaningful discussions on this crucial topic. Your insights have truly set the tone for the rest of this program, sir. Now, participants, let me remind you that after the lunch break, Dr. Chanda will take us through another exciting session on understanding inertia with zero-spin energy into the renewable-based synchronous grid. So we look forward to your continued participation. And before that, participants, please, before lunch, please ensure your presence in a group photo with our esteemed speaker. And after second session, there will be a AICT Idea Lab visit as a practical hands-on session. Okay, after the second section. So now participants, please be available for the photograph.